Hey everyone, a massive welcome to all of you joining Dr. Vinayakumar's Spardha Vinaya Educator class. I am absolutely thrilled you're tuning in today. If you're gearing up for the UPSC or KPSC exams, you already know that general science is a crucial battleground. Well, today we are going to conquer a real heavyweight topic together, Newton's second law of motion. And listen, we aren't just going to blindly memorize it. We are going to truly understand the mechanics behind it. That way, no matter how they try to trick you with a question on exam day, you'll be 100% ready.
So, here's our game plan for today's explainer. First, we'll nail down the definitions of force and momentum. Then, we're going to break down mass, acceleration, and the famous F equals ma formula. After that, we'll dive into some real-life applications. We'll follow that up with a quick UPSC and KPSC review, and stick around because we're wrapping things up with a rapid-fire pop quiz.
All right, Section 1, Force and Momentum Defined, the Foundations of Motion. Let's jump right into it.
Okay, first up is momentum. Now, for our local exam candidates, you really need to recognize the Kannada term here, which is Sanvega. Think of momentum simply as, well, mass in motion. You calculate it by multiplying an object's mass by its velocity, which gives us the super simple formula P equals m times v. Basically, if an object has mass and it's moving, it's got momentum. And it makes sense, right? The heavier it is, and the faster it's zooming along, the more momentum it packs.
But here's the big question. How do we actually change that momentum? Well, we use force, or in Kannada, bala. Newton's second law tells us that force is literally the rate of change of momentum. Whenever you push or pull an object, you're actively changing its momentum, and that change happens in the exact same direction as your push or pull. Grasping that force is the main driver of momentum change is basically the skeleton key to unlocking this entire concept.
Moving right along to Section 2, mass, acceleration, and F equals ma, the mathematical relationship.
So, the crucial point here is this world-famous equation, F equals m times a. Force equals mass multiplied by acceleration. In plain everyday language, this tells us exactly how much force you need to move something. It depends entirely on just two things: how heavy the object is, that's its mass, and how quickly you want to speed it up, which is its acceleration. It's actually pretty intuitive when you think about it.
Let's make this totally practical, okay? Imagine you're trying to push an empty truck. It's going to be really difficult, but it's possible, right? It takes a certain amount of force to get up to a walking speed. Now imagine that exact same truck, but this time it is fully loaded to the brim with heavy cargo. If you want to accelerate that loaded truck to the very same speed, you are going to need a significantly larger amount of force. Because the mass increased, the required force inherently increased right along with it.
Now we can actually flip that logic too. Imagine applying the exact same push to two totally different objects. If you push a really light object, it reacts with high acceleration. It just zooms away. But if you apply that exact same push to a heavy object, you get very low acceleration. It probably barely even nudges. So different masses react completely differently to identical forces.
Let's move to Section 3, real-life examples and applications, physics in the real world.
First up, the classic cricket catch. When a fast-moving cricket ball is coming right at you, it has incredibly high momentum. If a fielder holds their hands completely stiff, the ball stops instantly. The time of that momentum change is tiny, which means the force hitting their hands is massive and painful. But by pulling their hands back as they catch it, the fielder actually increases the time it takes for the ball's momentum to hit zero. More time stretching out the impact means way less intense force applied to the hands.
And you know, this exact same physics principle literally saves lives on the highway. Think about airbag safety in cars. In a collision, a passenger's body has a ton of forward momentum. If they hit a hard dashboard, their momentum drops to zero in a fraction of a second, resulting in a deadly amount of force. But when an airbag deploys, it cushions the impact. It extends the time it takes for the person's momentum to drop to zero. By stretching out that time even just a little bit, the intensity of the force hitting the passenger is drastically lowered.
Okay. Let's switch gears. Section 4, UPSC and KPSC exam review. High-yield study points. I want everyone to take a mental photograph of these exact definitions and units. You absolutely must know these pairs by heart for the exams. Force, or bala, is measured in newtons, which is exactly the same as 1 kilogram meter per second squared. Mass, or rashi, is measured in kilograms, and acceleration, or vega-karsha, is measured in meters per second squared. Seriously, jot these down, highlight them, memorize them. They are guaranteed points.
Here's another incredibly high-yield point. Force is a vector quantity, or sadesha parimana. What does that actually mean? Well, it means it isn't just a basic number. It has two distinct properties. First, magnitude. That's the actual measurable strength of the push or pull. And second, direction. A force pushing right is fundamentally different from a force pushing left. And remember, force always aligns with the direction of the momentum change.
Let's test that immediately with a quick visual scenario check. Try to mentally identify the direction of the force here. Number 1, a rocket launching upward. The thrusters push down, sure, but the net force driving the momentum change is moving upward. Number 2, brakes suddenly applied to a forward-moving car. The car's moving forward, but slowing down, so the force of the brakes is actually pushing backward against the motion. And number 3, pushing a stalled truck to the right. The applied force is, quite simply, directly to the right.
And that brings us to Section 5, the end of class pop quiz. Let's really test your understanding.
All right, question 1. According to Newton's second law, force is directly proportional to the rate of change of what? Is it A, velocity, B, acceleration, C, momentum or samvega, or D, inertia? Got your answer? If you said C, momentum, you are absolutely correct. Force is what drives the change in momentum.
Let's do question 2. What is the correct foundational mathematical formula for force? A. F equals m divided by A. B. F equals m multiplied by A. C. F equals m plus A. Or D. F equals A divided by m. The answer is B. F equals m times A, mass times acceleration.
Moving on to question 3, testing those real-world applications. Why does a cricketer pull their hands back when catching a fast ball? A. To increase the force. B. To increase the time of momentum change. C. To decrease the ball's mass. Or D. To increase velocity. The correct answer is B. By increasing the time it takes for the ball to stop, they significantly decrease the painful force on their hands.
Question 4. Force is a vector quantity, or sadesha parimana. This means it inherently possesses what? A. Only magnitude. B. Only direction. C. Both magnitude and direction. Or D. Neither. The answer is C. Vectors must always have both a measurable amount and a specific direction.
And our final question, making sure you remembered those crucial units. Question 5. What is the designated SI unit of force? A. Joule. B. Watt. C. Newton. Or D. Pascal. You guessed it. For sure it is C. The Newton, proudly named after the very physicist who gave us this law.
What an absolutely excellent session. That brings us to the end of today's class. A huge thank you to all the students for attending Dr. Vinayakumar's Spardha Vinaya Educator class today. Your focus was phenomenal. But before we part ways, I want to leave you with this thought. Knowing the formula is great, but seeing how force, mass, and time interact in the real world around you is what truly builds mastery. Keep studying, keep asking questions, and remember, understanding momentum is exactly what will make you an unstoppable force in your upcoming exams. But hey, Newton had 3 laws, not just one. So what happens when your unstoppable force meets an equal and opposite reaction? Well, we'll tackle that next time. See you in the next explainer.